Imagine if you could walk into your living room and all your electronics started charging without a single wire or plug needed. According to a team of engineers at Duke University and the University of Washington, this idea isn't too far from reality, and the technology already exists to build it. They say a single charger mounted high on a wall could beam power to several devices at once, from cell phones to smartwatches. While some wireless charging systems already exist to help power speakers, phones and tablets, they rely on platforms that require their own wires, and the device to be charged needs to be in the immediate vicinity of the charging station for it to work. But this new technology can charge a device that's anywhere in the room. The current technology for the wireless chargers that you usually find in coffee shops relies on resonant magnetic near-field technology to transfer the energy from the station to the device. This works by producing a magnetic field in a coil of wire, which induces a similar current in a neighboring coil, the device to be charged. This existing method is considered safe because magnetic fields aren't harmful to human exposure. However, it doesn't work for longer distances, but the new wireless power transfer system solves this problem. It uses higher frequency microwaves that can extend beyond the confines of a room. The research, published in the Journal of Applied Physics, was conducted in collaboration with the Intellectual Ventures Invention Science Fund. Dr. David Smith, professor and chair of the Department of Electrical and Computer Engineering at Duke University, said, "Whether it's headphones, cell phones, watches, or even your mouse and keyboard, a major irritation for consumers is the hassle of being tethered to cords to recharge batteries. And of course they always run dry at the worst possible moment. Our proposed system would be able to automatically and continuously charge any device anywhere within a room, making dead batteries a thing of the past." The panel is made of metamaterials, a synthetic material composed of many individual engineered cells that produce properties found in nature. These cells can be tuned to manipulate the waves in a specific way to make sure the electromagnetic field can focus on any device in the room, and not just one. According to the research, a flat metamaterial device no bigger than a typical flat-screen television could focus beams of microwave energy down to a spot about the size of a cell phone within a distance of up to 10 meters. According to Dr. Smith, as long as you're within a certain distance, you can build antennas that gather electromagnetic energy and focus it, much like a lens can focus a beam of light. Dr. Smith and his laboratory used this principle to create the world's first cloaking device that bends electromagnetic waves around an object held within. Dr. Nathan Kundtz, a former graduate student from Dr. Smith's team, led the ISF team that developed the metamaterial technology for the project. The ISF team founded Cometa, which builds powerful, flat antennas that could soon replace gigantic satellite dishes. One of the coolest things about our approach to this problem is that it allows us to manufacture our antennas at the same plant that produce LCD televisions, said Dr. Kundtz. LCD, liquid crystal displays, are liquid crystal integrated with the metamaterial elements that enable Cometa's satellite antennas. Dr. Matt Reynolds, a co-author of the study and associate professor of electrical engineering and computer science and engineering at the University of Washington, said, "The ability to safely direct focus beams of microwave energy to charge specific devices while avoiding unwanted exposure to people, pets and other objects is a game changer for wireless power." There are, however, challenges to engineering the system. A powerful, low-cost, highly efficient electromagnetic energy source would need to be developed. The system would have to automatically shut off if a person or a pet were to walk into the focused electromagnetic beam, and the software and controls for the metamaterial lens would have to be optimized to focus powerful beams while suppressing any unwanted secondary ghost beams. All of these issues are possible to overcome. They aren't roadblocks, said Dr. Smith. "I think building a system like this, which could be embedded in the ceiling and wirelessly charge everything in a room, is a very feasible scheme. Moreover, there are versions of the concept that can deliver larger power over much larger distances."